Welcome. If you're an automotive engineering leader, you know the future of mobility is being built, quite literally, on a foundation of advanced materials. So today, we're going to break down the core challenges that I know you're facing and explore some truly game-changing solutions.
Look, as an EV engineer, you're dealing with this fundamental conflict every single day, aren't you? On one hand, you've got these powertrains that have to endure just incredible punishment. But on the other, your customers are demanding a cabin experience that's, well, seamless, comfortable, and frankly, smarter than their living room.
And this leads us to what we're calling the engineering trilemma. You have to deliver a premium experience, you have to guarantee extreme resilience, and you have to achieve true circularity. So how do you solve for all three at once? The answer isn't about making compromises. It's about innovation, right down at the materials level. So here's our game plan for this briefing. We're going to dive deep into each pillar of that trilemma: experience, resilience, and circularity. And then we'll pull it all together into 4 strategic plays that you and your team can actually execute. Okay, let's kick things off with that first pillar, the cabin experience. We are seeing this massive shift away from static, boring surfaces and toward these incredible, interactive, and sustainable environments. And it's the material science that's making all of this possible. Now, this slide right here is fascinating because it shows such a giant leap. We're moving from a simple passive dashboard to this intelligent surface with dead front displays that are completely invisible until they light up. And you can thank advanced translucent polymers for that magic trick. And listen, we're not talking about some tiny incremental improvement here. These new soft TPO materials can hit 91% light transmittance. That's a huge jump from the typical 82%. And that extra brightness and clarity, that's exactly what you need for those crisp, hidden until lit displays we just saw. This innovation isn't just happening on the dashboard, it's completely changing the game in seating too. Polyolefins are making a huge difference in 2 ways. First, you've got Infinair with its open loop structure that gives you 6 times the airflow of old school foam. And then there's EvoAir, which is just this fantastic, sustainable, non-animal-based alternative to leather. And when you put them head to head, the engineering advantages are just undeniable. EvoAir is up to 40% lighter, it has 0 plasticizers, which means better air quality, and it stays flexible even at a brutal -30 Celsius. That's a temperature where traditional PVC just gets brittle and cracks. But a premium cabin, it has to be quiet, right? In an EV, you lose that constant hum of the combustion engine, which, believe it or not, used to mask a lot of other sounds. So now, those high-frequency whines from the motor, you can see them here as these sharp peaks, they become really noticeable and, let's be honest, really annoying. So what do? The solution is targeted acoustic foam. A material like beta foam can get you near perfect air tightness inside the body cavities, which can slash that noise by up to 35 decibels. But here's the really strategic part. It does this while being 55% lighter. Less weight means more range. That's a massive win-win. Okay, let's shift gears and move on to our second pillar, resilience. We're going to move our focus from the cabin to something just as vital, protecting the high-voltage heart of the EV from a really harsh world out there. I mean, the operating conditions for these powertrains are incredibly severe. We're talking about everything from deep water wading to fine desert dust, so that enclosure has to be perfectly sealed. But on top of all those physical threats, there's also the invisible danger of high-voltage arcing. This leads us to a pretty fundamental engineering problem. As temperatures swing wildly, pressure builds up inside these sealed housings. So how do you stop that pressure from just blowing out the seal and sucking in all kinds of contaminants? The physics behind this is something you probably remember, Paschen's law. What it means, in simple terms, is that if you get a compromised seal, you end up with a low-pressure, contaminated environment inside that housing. And in those exact conditions, it takes a much lower voltage to create a dangerous, damaging electrical arc. It's a critical failure just waiting to happen. Now, the solution here is just beautifully elegant. It's a breathable vent made from EPTFE. It has this micropore structure that's just big enough to let tiny air molecules pass right through, which equalizes the pressure. But the pores are 20,000 times smaller than a single water droplet, so it completely blocks out water, dirt, you name it. And you don't have to take my word for it. The proof is right here in the data. Just look at this. Competing products can fail from oil clogging in as little as 500 miles, but the Gore vent, with its pre-filter, breezes past 140,000 miles of durability testing. The gap in long-term reliability it's just enormous. All right, let's tackle our third and final pillar, the circular economy. We're going to look at how you can turn this from a regulatory headache into a genuine competitive advantage, all through smart material design. The motivation here is crystal clear. New EU regulations are on the horizon that will require 25% of all the plastic in a new vehicle to come from post-consumer recycled sources. And let's be blunt about this. It's not a suggestion. It is a non-negotiable requirement for market access. The solution is to think in a full circle, a closed-loop strategy. It all starts with using recycled feedstock. Then you manufacture circular resins. From there, you have to design your products with monomaterials, so they're actually easy to separate. And finally, you need a system to recover those raw materials at the vehicle's end of life. And this diagram just perfectly illustrates why this approach is such a game changer. Down at the bottom, you have a traditional seat. It's a mess of mixed materials and glues, so it can't be separated, and it just ends up in a landfill. But up top, you have a monomaterial polyolefin seat that can be shredded and recycled directly into a new part. There's no downcycling. It is true circularity in action. So we've seen all this amazing technology. The big question is, how do you turn it into a winning strategy? Let's boil everything down into 4 clear, actionable plays for your organization. So here it is. The performance matrix. This is what grounds all of our recommendations in cold, hard data. You can see all the key metrics we've discussed, all in one place. From that incredible 91% light transmittance for the visual experience, all the way to that 140,000 plus mile lifespan for core protection. And this data points us toward 4 very clear strategic directives. First, adopt monomaterials now. Get ahead of those regulations. Second, differentiate the user experience. Use those translucent materials to create a signature brand look that no one else has. Third, engineer for silence from day one to save weight and avoid costly fixes later. And fourth, protect the core. Standardize on proven venting technology and just watch your warranty claims plummet. So, this leaves us with a final thought. Material science isn't just a late-stage design choice anymore. It dictates your market access, it dictates your total cost of ownership, and it dictates your brand differentiation. The question for you and your team is, which of these 4 strategic plays are you going to prioritize first?